Cracking meaning, the word meaning, I always emphasize on understanding something new with the meaning of the word, because the real meaning in your bones or legs or cracking of a tree or etc., we actually mean here cracking of organic molecule, big molecule, which is hydrocarbon. Why they need to be cracked? Because some big molecules, very big, containing more than 20 carbon atoms in a big chain, and they are less useful. They can be used to have road surface. They are bitumen, and we don't have so many roads to coat them with the bitumen. But when they are useless, you don't need them. Then you normally discard. You like to discard them. But we need the fuel, gasoline here. We have greater demand of gasoline. So if we can break the long chain hydrocarbons of the bitumen, then we get smaller chain hydrocarbons. The smaller chain hydrocarbons are useful, more useful for their fuel, as they are a good fuel. This was the main objective of cracking, but after scientists started doing the cracking, so they got another more valuable thing, which is in cracking they get smaller hydrocarbons, and in this hydrocarbon they get some alkenes and get some alkenes, some saturated, some unsaturated. Both are smaller. After breaking the long one, they get smaller. Both are smaller that they get. And when initially they used to burn both of them to get heat or use them as fuel, but later they got that the alkenes there are more useful for chemical industry. They can make many things. Alkenes can be used to make many things. Suppose polymer here, detergent here, medicine in factory, and scientists are making many things with the alkenes. So alkenes are now more easy. So what is cracking? Cracking means breaking of long chain hydrocarbons, and when you break the long chain hydrocarbons, you get smaller ones, smaller hydrocarbons, and they are good as fuels, and some of them which are alkenes, they are also good as feedstock in different organic chemical factory, different factories, suppose plastic or etc. So this is why cracking is done. And in this cracking, you just cannot use a scissor to cut up the big chain hydrocarbons. You just need to heat them. If you just heat the big chain, long chain hydrocarbons at a very high temperature, suppose close to 800, 900, the big molecules turn into gas and then they collide with each other. When they collide with each other vigorously, the molecules break down. This is cracking, the molecule breakdown. But later the scientists got different way of cracking them, which is just using a catalyst with the temperature. When they have started using catalyst, which is zeolite catalyst, actually a mixture of aluminum oxide and silicon dioxide. Okay, a mixture of aluminum oxide and silicon dioxide. When you get in a question, you better write this too: aluminum oxide, which is alumina, and silicon dioxide, which is sand. So when you're mixing these two together and then mix with the long chain hydrocarbons on a heat at a high temperature. This temperature is less because you're using catalyst. This temperature is suppose 500, 600 degrees Celsius. So at this temperature, the big molecules break down into shorter ones. So this is the cracking. This is how we do the cracking. And the benefit is when you're using catalyst, you have less temperature. So temperature is only expensive matter. So now you have less temperature when you're using catalyst. This is a good thing with catalyst. Another good thing also with catalyst, which is actually using catalyst, the cracking gives more alkenes than alkenes. You already got earlier, I told that in cracking you get both alkenes and alkanes. You are getting both of them. But when you use catalyst, you get more alkenes than alkanes. This is another good thing using catalyst. And alkenes are more useful. They have greater demand and they are more precious. So because they are used in chemical factory to make many things, I told you. So this is cracking. Now go to another point, the equations. What happens to the equation? So we got the definition and we got the way of how this is done and why this is done. You get three questions here. So what is cracking? Could be definition, I already mentioned. Another is why is cracking done? Why do you crack? And third is how is this done? How is the process of doing cracking? So these three are common questions, and the next question would be equation. Actually, we do not break the small hydrocarbons, but for our learning, for our practice, we are using some small hydrocarbons to break. If you learn this, breaking small hydrocarbons or writing them in equation, then you can also be able to write equations with big hydrocarbons. I show you first one. This could be C6H14. When this is broken, there are many possibilities of breaking these hydrocarbons. Suppose you got a glass of water, and if you fall this from your hand, and that breaks down into smaller pieces, and how would that break? This is not certain. So same thing happen here. When this molecule collide with other molecules, so this will break down. But how would that break? This is not certain. But one way you can generalize. What is that? When you have then alkane, suppose I write here alkane. This is an alkane. When that breaks down, you get alkane and alkene. This is the common thing, very general. Alkane and alkene, that you may get there. So now we start with this example, C6H14 and alkane. When you break them, and suppose initially you think of breaking this at the middle. Middle means C3. Here's 6 carbon and middle is C3, and think that this is an alkane. So what would be the hydrogen number? 8. 8 is the hydrogen number. And another 3 is here because 6 carbon, another 3. And this would be alkene, 6. Why alkene? Why alkene? Because the hydrogen number is 14. After breaking an alkane, you never expect to have 2 alkane, because if you make 2 alkane, you would need 2 more hydrogen atoms. Okay, suppose here you get alkane with 8 hydrogen, alkene with 6 hydrogen. When you add this hydrogen with this hydrogen, you get this number of hydrogen. So this is why they form alkane and alkene generally. But one thing is important, I just have broken them at the middle, but it's not necessary that they will always break at the middle. This maybe here this breaks at the beginning, CH4. Here 6 carbon, just 1 carbon breaks down to give alkane, and this is CH4. Then after 1 carbon gone, you have another 5 carbon. With this 5 carbon, C5 and H, how many H should be there? 10. Get 10 because alkene. This is an alkene. Or you can break anywhere. I show you. Suppose this is C2H6. I'm writing here this is an alkane, C2H4. And how many carbon still remains there? 4. So I write C4 and H8 because this would be alkene. And they could be also opposite, which means you may make this an alkene. This is C2H4, and here write C4H10 would be here, because now I'm writing alkene. So this is how you can write alkane and alkene. Most of the cases this happen, an alkane and alkene. And there is another option too, when a big chain hydrocarbon is broken, both of them giving alkenes. But when this happens, both of them form alkenes, then another additional hydrogen will form with that. I show you. Suppose I'm writing this. This is an alkene. I write again alkene, and this also alkene. Right, C4H8. So now this is an alkene. This is an alkene. This also form, and when this form, the balancing is C2H4 is C4H8 because they are alkene. How many hydrogen here? 4. How many hydrogen here? 8. When you add this to hydrogen, how many get? 12. But you started with 14 hydrogen. So 14 hydrogen here is 12 hydrogen. So there must be another hydrogen formed. So these are there. Simply, these are there. You need to write equations with a small molecule. They will not give you very big molecules. For big molecules, the equations are almost similar. Example, suppose starting with 50, then how many hydrogen should be there? 62. Think that this is an alkane, and if you break this in cracking, then at any portion, at any part of the long chain hydrocarbon that may break, we just think of C10 H22. I'm writing this on an alkane, C10, because double and 2 more, and 10 carbon already gone. How many carbon do you have? 20. So I write C20, then H is 40. This is an alkene. And they may be opposite. The first one could be C10 H20 alkene, and second one could be an alkene, C20 H42. These are all about cracking. I think these are clear. You need to have some more equation, writing equation.